Welcome, dreamers and stargazers, to a voyage that will carry us far beyond our world. Tonight, we're exploring the mysteries of the universe, its edges, its origins, and the wonders that lie just out of reach. Find a cozy spot, maybe a blanket or a comfy chair, and take a deep breath. Let your shoulders relax. Close your eyes for a moment. Can you feel the vastness of space calling you? In the next half hour, we'll journey from our tiny blue planet to the farthest reaches of existence, unveiling secrets that spark awe and curiosity. This isn't just a trip through space, it's a chance to wonder, to imagine, and to drift into the cosmos. So, are you ready? Let's slip into the starlight and begin. Let's begin where we are, Earth, a shimmering blue jewel in the vastness of space. It's the third of 8 planets orbiting our sun, a fiery star at the heart of our solar system. Picture Mercury, scorched and barren, Mars with its rusty canyons, Jupiter's swirling storms, and Saturn's rings gleaming like cosmic jewelry. Beyond lie the asteroid belt's rocky fragments and the icy Kuiper belt, home to distant worlds like Pluto. Did you know? Each planet has its unique characteristics. Venus is wrapped in a thick carbon dioxide atmosphere with surface temperatures reaching 462 C, hot enough to melt lead. Jupiter has 67 known moons, the largest 4 Io, Europa, Ganymede, and Callisto first spotted by Galileo in 1610. Each is a world unto itself. Io covered with active volcanoes, Europa possibly hiding life, harboring oceans beneath its icy shell, Ganymede larger than Mercury, and Callisto peppered with impact craters. Now zoom out. Our sun is one of 200 billion stars in the Milky Way, a spiral galaxy stretching 100 light-years across. A light-year is how far light travels in a year, about 9.5 trillion kilometers. We're nestled in the Orion Arm, 27, 0 light-years from the galaxy's glowing core, a supermassive black hole. Imagine this. You're floating above Earth, watching it shrink to a pale blue dot. The solar system fades, and a sea of stars surrounds you, twinkling in the dark. We humans live in a surprisingly advantageous position. The sun sits in a habitable zone of the galaxy, far from dangerous starbursts and gamma ray bursts. Our Jupiter acts like a cosmic shield, its powerful gravity attracting many asteroids and comets that might otherwise strike Earth. The moon's presence keeps our axial tilt stable, creating the seasons conducive to life. So many cosmic coincidences have made our existence possible. Take a moment, close your eyes, and picture yourself drifting through this starry ocean. What does it feel like to be so small, yet part of something so grand? Our solar system is just a tiny village in the universe's endless city, but it's home. Our Milky Way is a dazzling spiral, its arms swirling with stars, planets, and glowing nebula clouds where new stars are born. At its heart lies a supermassive black hole, silently shaping the galaxy's dance. But the Milky Way isn't alone. It's part of the Local Group, a cosmic neighborhood of about 50 galaxies. The largest is Andromeda, our sister galaxy, even grander than ours, sparkling 2.5 million light-years away. The space between galaxies isn't truly empty. It's filled with tenuous intergalactic gas and dust, primarily hydrogen and helium, with traces of heavier elements. Within this seeming void exists unexpected beauty in gorgeous emission nebulae, where gas glows from the ultraviolet radiation of nearby stars. The Orion Nebula is one example, a stellar nursery about 344 light-years from us, spanning 24 light-years of space. Our Milky Way moves at about 792 kilometers per hour, and it's getting faster. Much of this acceleration is due to the gravitational pull from a mysterious region that astronomers call the Great Attractor. It's the location of a group of galaxy clusters outside our galaxy with a combined mass equal to 100 trillion suns. In about 4 billion years, the Milky Way and Andromeda will meet not in a crash, but in a slow, graceful merger. Stars will weave together over millions of years, forming a new elliptical galaxy. Picture it like a cosmic waltz, galaxies blending in a dance that reshapes the heavens. It's not destruction, it's creation on a scale we can barely fathom. Let's pause. Imagine you're hovering above this scene, watching the Milky Way's spiral arms tangle with Andromeda's. What colors do you see? What does this vast ballet feel like? This is the universe at work, crafting beauty across eons. Now, let's soar higher. Galaxies don't float alone, they gather into clusters, like towns in a cosmic landscape. Our local group is part of the Virgo supercluster, a massive collection of over 500 galaxies. But even this is just a thread in a grander tapestry cosmic web. Picture it. Filaments of galaxies stretch across the universe, glowing like strings of pearls. They meet at nodes, forming clusters, while vast voids empty spaces lie between. One of the largest structures we know is the Sloan Great Wall, a galactic chain over 1 billion light-years long. It's like a cosmic highway stretching beyond our wildest dreams. Diving deeper into these astonishing large-scale structures, we find mega-complexes like the Perseus-Pisces supercluster, one of the largest known structures in our universe, spanning over 1 billion light-years. This giant wall contains millions of galaxies, interwoven in the most prominent part of the cosmic web. Only in recent years, as we've built detailed three-dimensional maps of galaxies, have these grand patterns begun to emerge. This web was woven by gravity over billions of years, pulling galaxies into patterns we're only beginning to map. The process is one of contrast. Regions of slightly higher density attract more matter, becoming even denser, while lower density regions become more void-like. Over billions of years, this simple interaction has created the complex structures we see today. Close your eyes for a moment. Imagine soaring through this web, passing glowing galaxies and diving into dark voids. What does it feel like to glide through the universe's framework? This is the cosmos on its grandest scale. We've reached the edge of what we can see the observable universe, a sphere 93 billion light-years across. Why a limit? Light travels at a finite speed, and the universe is 13.8 billion years old. The farthest galaxies we see are 46.5 billion light-years away. their light showing us how they looked billions of years ago, when the cosmos was young. This apparent contradiction in a universe 13.8 billion years old, yet with objects visible at 46.5 billion light years away, demonstrates the astonishing power of cosmic expansion. As light from a distant galaxy travels toward us, space itself stretches, pushing the source of the light farther away. That's why the diameter of the observable universe isn't the expected 27.6 billion light-years universe age multiplied by 2, but an astonishing 93 billion light-years. But here's the mystery. The universe might be far bigger, maybe infinite. Beyond our view, there could be more galaxies, stars, even life we'll never see. It's like standing on a shore, the horizon hiding distant worlds. The James Webb Space Telescope is helping us peek further, but some secrets stay out of reach. Imagine the frontiers of universe observation. The first images from the Webb telescope show us galaxies as they appeared just 300 million years after the birth of the universe, the dawn of cosmic history. These primitive galaxies are brighter and more organized than expected, challenging our understanding of early formation. With its infrared observations, Webb can penetrate cosmic dust clouds, revealing previously hidden star-forming regions and details of distant galaxies. Pause for a second. Picture a universe stretching forever new stars, planets, possibilities. What might be out there, just beyond the light? This is where science meets imagination, and we wonder what else the cosmos holds. Let's travel back to the start 13.8 billion years ago, when the universe began with the Big Bang. It wasn't a blast, but an expansion of space itself, born from a hot, dense point. In moments it grew, cooling to form particles, then atoms, stars, and galaxies. The cosmic microwave background, a faint glow we can still detect, is proof of that fiery birth. According to the standard cosmological model, the universe underwent a phase called inflation during the first second after the bang, expanding by at least a factor of 1026 in just 1036 seconds. This phase explains why the universe appears so uniform in different directions and provided the seeds for the structures we observe today. Following this, the universe continued to expand and cool, allowing the formation of fundamental particles like quarks, then protons and neutrons, and eventually simple atoms like hydrogen and helium. The first stars were born about 100-200 million years after the universe's birth, massive, super-hot blue giants that lived short but powerful lives. When they exploded, they released heavier elements into space carbon, oxygen, iron that would eventually form planets and life. Every atom has a story. The carbon and oxygen atoms in your body were forged inside the cores of stars billions of years ago. The iron in your blood came from supernova explosions. The gold and platinum in your body may have been produced in neutron star collisions, one of the most violent events in the universe. Today, the universe keeps expanding and it's speeding up. A mysterious force, dark energy, makes up 68% of everything and drives this growth. Dark matter, about 27%, shapes galaxies with its gravity, where the rest just 5% of ordinary matter, like stars and planets. Imagine the universe as a balloon stretching wider, galaxies drifting apart. Close your eyes and picture its space itself growing, carrying everything along. What does it feel like to be part of this endless unfolding? This is the story of our cosmos, written in light and mystery. So, does the universe have an edge? It might be infinite, stretching forever. Or maybe it's finite but boundless, like the surface of a sphere you travel far and end up back where you started, with no wall to hit. Then there's a bolder idea. Our universe could be one of many in a multiverse. Picture bubble universes floating in a higher dimension, each with its own rules. Maybe gravity works differently, or stars glow green. String theory hints at this, suggesting reality has layers we can't see. Beyond our cosmos, there could be realities we can't even dream of. Some multiverse theories proposed by physicists include the quantum multiverse or many worlds interpretation, where each quantum event creates a new branch of reality. The inflationary multiverse, where ongoing cosmic inflation creates bubble universes that never meet. The cyclic universe, with endless cycles of big bangs and big crunches. The brain universe from string theory, suggesting our universe is a membrane in higher dimensional space. These grand ideas raise questions about the specialness of our universe. Physicists have noted that the physical constants in our universe seem finely tuned to allow life. For example, if the strong nuclear force were just 0.4% stronger, hydrogen wouldn't exist because all protons would bind into helium. If it were 2% weaker, heavy elements couldn't form. Is this coincidence? Or are we simply seeing the rare part of a grand multiverse that's suitable for life? Let's pause. Imagine another universe, one completely unlike ours. What do you see? A sky of new colors? Worlds with strange laws? This is where science dances with wonder, leaving us with questions as vast as the stars. We live in 3 dimensions: length, width, height, plus time as a fourth. But what if there are more? String theory suggests up to 11 dimensions, curled up so tiny we can't see them, shaping reality in secret. Then there's quantum physics, where particles can be in 2 places at once or linked across galaxies through entanglement, a spooky connection Einstein couldn't believe. As we delve into the quantum realm, astonishing phenomena become apparent. Particles behave as waves, passing through double slits and interfering with themselves. The uncertainty principle limits our ability to know both a particle's position and momentum simultaneously. Quantum tunneling allows particles to pass through barriers they classically couldn't overcome. The act of observation itself influences the system being observed. In laboratories, scientists have created entangled particles that maintain their eerie connection when separated by kilometers. The 2022 Nobel Prize in Physics was awarded for experiments proving Bell's inequalities, confirming that these strange predictions of quantum mechanics are indeed laws of nature, not merely mathematical constructs. This leads to deeper questions. Why does the universe exist at all? Why does math describe it so perfectly? What is consciousness, your ability to wonder about these stars? Imagine you're a spark of the cosmos, asking itself what it is. The universe might be alive in your thoughts. Take a moment. If you could ask the cosmos one question, what would it be? Picture it echoing through the stars. These mysteries remind us how little we know and how much there is to dream about. One of the greatest puzzles in modern physics is unifying Einstein's theory of gravity, general relativity, which describes the large-scale universe, with quantum mechanics, which describes the smallest scales. The two theories seem to conflict where extreme gravitational fields meet quantum effects near black holes and during the early stages of the universe. String theory is one candidate solution for quantum gravity, suggesting that fundamental particles aren't point-like objects but tiny vibrating strings of energy, whose vibration patterns determine the properties of the particle. In this theory, gravity is carried by a hypothetical particle called the graviton, just as light is carried by photons. Another competing theory is loop quantum gravity, which proposes that space itself is quantized, with minimum units of area and volume at the Planck scale, about 10^35 meters. These theories are extremely difficult to test because the energy levels required are far beyond our current technological capabilities. Recently, theoretical physicists have proposed the holographic principle, which suggests that all the information in our three-dimensional world can be completely encoded on a two-dimensional surface, like a hologram. This startling idea, derived from studies of black holes, suggests that the universe may be stranger and more interconnected than our intuition would suggest. If we ever unravel the mystery of quantum gravity, we might redefine our entire understanding of time, space, and even causality. It could reveal new dimensions, possibilities for time travel, or explain the true nature of the universe's origin. In our exploration, let's consider a provocative question. Is there other life in the universe? Life on Earth is astonishingly diverse, from tiny bacteria to vast coral reefs, from the deepest trenches to the highest peaks. Life has found ways to survive in every imaginable niche, displaying incredible adaptability. In our galaxy alone, there are hundreds of billions of stars, many with planets orbiting them. Just in our neighborhood, astronomers have discovered over 50 exoplanets, many in the habitable zone, the distance from their star where liquid water is possible. Given these numbers, it seems unlikely that we are the only form of life. Yet, in what's called the Fermi paradox, if the universe is teeming with life, why haven't we encountered any evidence of it? Perhaps intelligent life is rare, or civilizations tend to self-destruct, or advanced species choose not to interfere with young civilizations. Or maybe the universe is so vast that even in a busy cosmos, civilizations might never meet. Consider our planet's unique history. The Moon was formed by a Mars-sized planet impacting the early Earth, a rare configuration that stabilized our orbit and made Earth a good home for life. Jupiter's massive gravity directs dangerous comets to safe orbits. Our unique plate tectonic cycle carbon regulating our climate. Does this combination of lucky factors make you wonder, is life a common cosmic phenomenon, or are we a cosmic miracle? As you gaze at the stars, think about this. What connection might you have with the countless life forms we might share this universe with? As our journey nears its end, let's come home to ourselves. We're small, living on a speck called Earth, orbiting an ordinary star in an average galaxy. Yet we're extraordinary. You, me, everyone were made of stardust, forged in ancient stars billions of years ago. Our curiosity, our questions, make us part of the universe's story. The human brain may be one of the most complex structures in the universe, with nearly 86 billion neurons, each potentially connected to as many as 10 other neurons. This complexity allows us to contemplate the universe itself, create mathematics to describe it, compose music to celebrate it, and dream of traversing it. In some way, the universe has organized itself to the point of understanding itself through us. We've sent robotic explorers to investigate our neighbors. Voyages 1 and 2 are now entering interstellar space, carrying records of Earth music, sounds, and images that might drift through the cosmos for billions of years, a testament that we once existed. The James Webb Space Telescope is now studying the first galaxies that formed. Juno is examining Jupiter's secrets, and the Perseverance rover is searching for signs of ancient life on the Martian surface. When you look at the sky, you're not just seeing stars, you're seeing yourself, a piece of the cosmos, awake and wondering. Carry this awe with you. Let it light up your dreams, your thoughts, your days. The universe isn't just out there, it's in you, in every question you ask. Good night, stargazers. Whether you drift to sleep or gaze at the stars, may this wonder stay with you. The cosmos is vast, but so is your heart. Thank you for soaring through the cosmos with me. The universe is vast, but your imagination is vaster. As you relax tonight, let these mysteries spark new dreams, maybe a new star, a new question. Sleep well, or keep wandering under the night sky. If you enjoyed this journey, hit that subscribe button for more cosmic adventures. Until next time, good night and keep looking up.